Hey, good evening, everyone. I hope you're doing great. If you can hear me, please type 1. Okay. This is the add class code. Can you please confirm that if it works? I'm gonna type it here. And those who join later, please just help them by passing the code. Awesome, thank you. The thing is today, we are going to start chapter 3. And tomorrow we are going to start our hands-on working on the real project. So these are the things that are needed to start our project tomorrow. It's going to be the second network that we're going to make in this semester. So chapter 3 is all about working on 3 different models. 2 of them are classification models, and one of them is scalar regression. So the binary classification is defined in 2 different ways. Some people say if you have something like cat and dog, we can say it is a binary classification. Some people narrow down that binary classification into cat or not cat. So we cannot say cat and dog could be binary classification. With any of these definitions, we can say positive or negative, or a little bit narrower compared to the first, we can say positive and not positive. So we are going to talk about that. And multi-class classification means that we have a text and we want to classify it into different classes, like if it is a sport, politics, stock, whatever it is. And the regression is about predicting the price of a house based on the features that we have, like how far it is from a highway, the proximity to schools and other services, or the crime rate, or the measurement of the house based on feet, square feet, and the other parameters. So we want to have that in our regression. Guys, if you can hear me, please type 1. Okay, so the next thing that we need to mention, there's just one thing I have forgotten to make. Just give me a second. Okay, the caption show caption English. Okay, guys, can you just confirm that you can see the caption if you want to see the caption? Can you see the caption at your end? That is something that one of the team members wanted. Okay, Algor, can you, Lucas, thank you, but this is something like this. Can you make it? So I'm gonna just bring it outside the scene. I just want to make sure you can activate it at your end without, because I didn't want to distract people. Some people found it distracted. So Algor, can you please just tell how you can activate that? This is something that they asked me from accommodation center, so I just want to make sure that I follow the regulations that they want. Okay, meanwhile, that Algor is kind enough to just tell us what to do. So you can click on CC on button tab. So it's gonna just show you the caption, I guess. Right? Okay. Perfect. And if you want, you can hide it. Am I right, Algor? So you can just hide it and it's not gonna distract you. Okay, bravo. Thank you very much. That's pretty much what I wanted. Before I dive deep into the content of today's session, I want to tell you, because I received a few emails from our team members asking for having a one-day extension. So by tonight's midnight means tonight 11:59 p.m. If anybody wants to resubmit or even submit for the first time, there is no time penalty for that. So unofficial extension means no penalty to submit the assignment by tonight's midnight. My pleasure, not a problem. And I'm gonna keep the assignment folder for 2 more nights. So Wednesday midnight, I'm gonna close it. So if you have no time to submit it and you want to submit it either tomorrow or the day after tomorrow, you have 2 more days for late submissions. That's a kind of standard. I do not announce it because I don't want to overwhelm with announcements. We just want to make sure that everything is smoothly, just defined for you guys. Let's go to the next part. If there's any question, any concern, please let me know. Otherwise, I'm going to just continue. Okay, so the classifying movies reviews as positive or negative. Now, this is something that this is one of the most common things that we use in the world of machine learning as well as deep learning, to say that we call it sentiment analysis, to feel that if the sense of one review comment is positive or not positive, because we might receive lots of comments, millions of comments, and we do not have time to go and review them one at a time. So one of the ways that we used before was using 5-star mechanism, but to complete that, we can just have sentiment analysis based on the reviews that we have for any product, right? The other thing is classifying news wires by topic. And for doing that, just please pay attention to this fact that we have multi-class classification. Means that it is possible, for instance, if we say Chelsea sold its stock in the market. So technically, partially it is a sport news, partially it is a economic news, but we are going to just assign single label in our practice for this just Reuters news wires. We just want to have multi-class single label. The question is it possible to define multi-class, multi-label? The answer is yes. We have already used it in our daily life when you want to have multiple people tagged in your Facebook, for instance, or you want to classify a news into several categories, right? And the last one is estimating the price of a house given real estate data. And I told you that proximity to highways or schools, and the crime rate, the size of the house, the number of bedrooms, and so on, the year that they have built the house. They are all the factors that bring us to the price. Please pay attention. The prices do not look very realistic. And the reason for that is they have gathered the information from 1980s. That is why the price of the houses are between 5,000 to maximum $40,000 back to 1980s in United States. So by the end of this chapter, you'll be able to use neural networks to solve simple machine problems such as classification and regression over, please pay attention to this word, vector data. Means this is just, yes, Lucas, bravo, means that we are going to work with something pretty close to the Excel file that we have, right? Okay, so let's get to the next part. It says that as you saw in the previous chapter, training a neural network revolves around the following objects. So we need to have layers which are combined together and shape our network, the input data and corresponding target. And we are about to find the relationship between these two. But because at the beginning, we assign the values for weights, I'm going to show you in one page in the book that it says for weights and biases, but in many references they say the initial values for the weights are random and for biases are zeros. But we have both kind of definitions. So because they are random, we are not gonna have a great result in our first attempt. So the loss function is there to show how far from perfection we are, and that defines the feedback signal that is going to be fed by optimizer. So optimizer is responsible to tweak or change biases and weights. In other words, the network parameters, right? And by doing that, we try to make our model better and better to lower down the gap between the labels that we already have and the predicted labels that we generate based on our model. In other words, y minus y prime. If everything is clear till this moment, would you please type 2? Okay, so this is what we see, the gap between these two with the help of loss function creates the loss score for us, and it's going to fit the optimizer. One of the problems is solved in the new edition, and that is showing that we change weights in here and we change weights in here. But the problem that still exists in the second edition is it doesn't show anything about biases while we are tweaking biases as well. Again, for the second time in this book, we see this phrase, this sentence. It says that the fundamental data structure in neural network is the layer. So what we can say distinguishes deep learning from other machine learning approaches, which mainly are shallow learnings, is the concept of having several layers. And the thing is, some layers are stateless in general, and we're not talking about the deep learning. What does it mean by stateless? Anybody can just step in and say something about stateless? Okay, the state means what? Means we have a status saved in our neurons or our weights or something, right? We have something saved somewhere that is stateful. But stateless means whenever we run the code again, we start all over again. Means we reset all the values that we have and we do not store it for the second round. By that definition means every time that we show a picture, we should use random weights and biases, and we don't care about the things that we have done before. What do you think? Do you think that the network is the network that we have in deep learning is stateful or stateless? It's a simple question and not trick question. Ali, correct. I repeat my question. So whenever you show a picture, it is going to just go from the beginning all the way to the end, right? Or a handwritten digit. Imagine that we show it starts from here all the way to the end, and we are going to have some weights and biases, right? So stateless means that I'm going to show another picture, and it's going to start all over again without taking care of what we had before for weights and biases. Do you think that is the way that we handle in deep learning? So PK said stateless. Ali defined stateless means that there is no memory. Do you think that we have no memory for the next round? What do you think? Al Gore says stateful. Yes, actually it is stateful because we are going to have and save those values, and when we get back to the beginning, right, and just bring another one, right, and we see that, okay, it should be 1, but it shows 5, we use that loss and we ask optimizer to tweak all those weights and biases. So it's going to be meaningless if we start from the scratch and randomize all those values without paying any attention. So technically, in that case, we never could have any correct answer at the end because we don't have any improvement every time you start from 0. I repeat it. Technically, whenever you, for instance, the number that we have is 5, and it shows that it is 1, for example, we are going to go all the way using back propagation, right? We are going to tweak all those weights and biases, and we make it show it is 5, right? So technically, we change all those weights and biases in that case. And for the next round that I'm going to show another number like 4, I already have some values. And if I just say, okay, you know what, forget it, stateless, I'm going to start all over again. So I never can have any progress. I just need, for instance, now it shows that it is 2, while it is not correct, and I expect to have 4. And if I change everything and I go to the next digit, which is, for instance, 7 this time, there is no saved values for weights and biases. Does that make sense? If we don't save, we don't have progress. We always do random things. If it is clear, please type 1. If it is not, please ask which part you have concern, and I'm going to explain again. Okay, by saying that, we say some layers are stateless, but more frequently layers have a state. And by saying that means that the layers weight one or several tensors learned with stochastic gradient descent. You remember that we talked about that. We can just use the stochastic gradient descent to fix, and that's the job of optimizer, which together contain the network's knowledge. We said, where do you think the knowledge of the model exists? And we talked about it. It exists in weights and biases. Guys, what is the other name for weights and biases? Lovely, Al Gore. Yes, Lucas, bravo. Yes, yes. Weights and biases are the parameters of the system. In other words, the things that system is responsible to tweak and to provide better results for us is nothing but, as you said, weights and biases. So these are parameters. What are hyperparameters, if I may ask? Lovely. One sample is epochs, batches. Lovely. What else? like number of layers. Yeah, number of layers, for example, or number of neurons in each layer. Anything that we are responsible to define would be in the category of hyperparameters. Mostly whenever we talk, we either want to address number of layers, the number of neurons in each layer, and so on and so forth. Okay, so it talks about now different forms of the input that we could have, like a simple vector data, which is a 2D, which we have some columns and every row is only an example. For 3D, we have sequence data. It is like we have something like 2D, but several sheets, and every sheet, for example, belongs to each day, right? Something like that. And for 4D, we can have the image data, and for 5D, we could have videos. And this is an important thing that we need to consider, that whenever we stack the layers, we do not need to take care of the input of each layer, because automatically the network would assign the number of outputs of the previous layer as the input layer of the current layer. I repeat it. The network automatically assign the number of outputs of the previous layer as the number of input of the current layer. So that is why it says that you can think of layers as the Lego bricks of deep learning. And it says that the notion of layers compatibility here refers specifically to the fact that every layer will only accept input tensors of a certain shape and will return output tensors of a certain shape. Look at here. It says that because we want to define a layer which has 32 neurons, and when I talk about these 32 means the current layer, we say that the input shape contains 784.
How are you? Good. This is yours, and this is Tejun. He also loves his dog.
Okay, just give me a second. Apparently, one of our team members don't know that. Okay. So, guys, can you hear me clearly? Okay. This is I can say a bug of the system. I don't know if it is, we can consider it a bug or not. But whenever your network is disconnected and when you reconnect it to the network, automatically it opens your microphone without your awareness. So not a bad idea to know that. So let's go to the next part together. And it says that we are creating a layer that will only accept as input 2D tensors, where the first dimension is 784. And the the batch dimension is unspecified. Think about it, why we do not specify that. Or the better question could be, where do we specify that? Just think about that in here. When I show you this, we just say every single picture has 28 by 28 picture, right? 20 pixel. And we don't say, for instance, we have 60,000, right? So think about it. Where do we use that 60,000 concept in our network? Do not answer it at the moment. Just think about it. We are going to get to there in no time. This layer will return a tensor where the first dimension has been transformed to be 32. And it says that when using Keras, you don't have to worry about compatibility. I already told you it's going to find it by itself, because the layers you add to your model are dynamically built to match the shape of the incoming layer. Does that make sense? Is there anyone who has any any comments about this line? This is something that we said. You remember in the video, that 20 minutes that I shared with you, the gentleman didn't use the input shape for the MNIST. The tensor transformation, so tensor transformations take place automatically due to Keras utilities. Exactly, that's the best way to put it in the words. Yeah. So now, can you please tell me how many hidden layers we have in this place? We haven't completed to show, but how many hidden layers we have here? Lovely, excellent. Exactly, Nash, Lucas. The thing is, here we have two hidden layers, but we have one input layer. And for this one, we didn't say. Well, we could say, but it's not necessary to say that the input shape of this one is 32. Automatically, it's going to adjust that. Huh? Okay, it says that the second layer didn't receive an input shape argument. Instead, it automatically inferred its input shape as being the output shape of the layer that came before. So one of the things that we need to consider is deep learning model, the way that we explained, are directed a cyclic graph of layers. What does it mean by directed? Please tell me, whenever we give a picture, is it possible, you know, that it goes from this and it goes all the way to all of them? So I don't want to, and it goes to the other and it goes all the way finally. So you know that for this one, I have to draw a graph like this. So directed means we have direction. So it goes from left to right. I'm not talking about the time that you want to calculate the loss and you want to use back propagation. I'm talking about the time that you have a digit. Imagine that you have 2 here and you want to fit it to your model and go and predict which one is the output. Is it clear that what directed means in the sentence? Means we have direction from left to right. It's like an arrow. You cannot go back from there. Does that make sense? If it is clear, we go from left to right. Please type 1. Okay, as an imaginary network, I'm not saying that neural net is like that, but imagine that you can go from this to this one. This is 2, and then you can go back. Just imagine for a second, you can go back here to 3, and then you can get back to where you started, right? Like this one. Guys, do you see that there is a cycle here? Do you see that there is a cycle here? If yes, please type 2. I'm saying I fabricated. We don't have such a thing. But do you see that from 1, I went to 2, and then 3, and I got back using that 3 rows? Do you see that we have a cycle? Means that we went from here, we went from the other, and we went somewhere else. And whenever you have a chance to go to where you have started, we call it a kind of cycle, right? Do you see that we have a cycle here? Huh? Thank you, Lucas. The rest? Okay, awesome. And now I'm asking you, let me just bring it back. Thank you very much. Now I'm asking you, do you think that we have cycle? Yes. Yes, that's what I want to get to, Lucas, to explain that line. Do you see in neural network, do we have any cycle when we start from somewhere? Are we going to get back from somewhere to where we started, yes or no? Lovely, you got the answer. So that is why, look at this one. So if you search for something like directed acyclic graph, means that you start from somewhere, you go forward, and you never have any kind of return. This is what we call directed acyclic graph. So in graph theory, in bachelor level, people have one course and they learn different graphs. So cyclic is one of them, and we don't need to go very deep inside that. We just need to know we have such a concept and we don't have any return. Let me just bring this one for a sec into here. Control V. I'm going to get to the answers. Imagine that for any reason, if I use a different color. If I have something from here back to A, because then I could have a kind of path that goes back to where I started. This is not going to be a cyclic again anymore. It's going to be a cyclic. So not a cyclic, it's going to be cyclic. So the question that I received from Enes is, if there was, it takes the benefit of neural network, then we do not need to make that many connections if it needs to come back. Yeah, you're right. And the thing is, Enes, even when we have a number here, and we say that if it is 1, 2, 3, and we just, again, back propagation is another directed acyclic graph, means we start from this time right to left, and we do not have any cycle, and we do not have any return, and the direction would be this time from right to left. So that's correct. I'm saying at the beginning, when we have not the weights and biases correctly assigned, then we work on changing the values, and we start changing this one, and then we go back and we go back. But still, it is directed and cyclic. We are not going to return to any values before. So by saying that, just remember, this is one of the most important things. And the second important thing is, guys, what is hypothesis space? Just read the sentence and paraphrase it and write it again for me. So these two are super important. You can guess why. What is a hypothesis space? A set of rules. The hypothesis space is mostly about the topology of a network. And what is the topology of the network? The number of hidden layers, the number of neurons in each hidden layer. They are gonna provide hypothesis space for you. You remember that we said for machine learning, we just search for appropriate tools. We don't create that. So the choices are the hypothesis, probabilities are, and possibilities are very much limited, right? But here we are going to create the tools for ourselves by defining hypothesis space. By saying that means that you can just define the number of layers, number of neurons in each layer, and so on and so forth. Is it clear? So the topology of a network defines a hypothesis space. Okay. And if you read that, it says that searching for useful representation is what happens in machine learning, but we define our own topology, and we define our own hypothesis space by defining the number of hidden layers and the number of neurons. One of the questions that I want to ask you guys, can you please tell me what could be the difference between a skillful deep learning data scientist and a novice in this area, one who just finished reading one book or passing one course? What makes a person a senior data scientist compared to somebody who just passed the courses? Well, I'm sharing that in the previous week for one of the companies. I was in the process of their committee that they wanted to hire. So the factors that they wanted to see is how many real projects the person has done. And apart from, for instance, if that person has certificates in artificial intelligence or anything else, exactly the projects, the experience that they had in their resume was one of the decisive factors to, efficiently choosing good optimizer loss functions. Or so that happens through what Ali said, Lucas, absolutely. Why I'm saying that, because this is the next thing that we need to consider, and it says that picking the right network architecture is more an art than science. So it doesn't mean that, for instance, is it based on math? Is it based on, I don't know, logic? Is it based on what? It's an art that you're going to achieve during the years of experience. Again, I can't emphasize enough on this sentence. Just read it and read it twice because of two reasons. One is because you're going to have it pretty soon. Second, because this is the gist of what, if you want to apply for similar like data engineer or data scientist positions, they want you to show what are you capable of by showing the certificates that you have in the field plus the projects, and if you can provide any co-op or any relevant job that you have done in the real world. So only practice can help you become a proper neural network architect. Getting back to here, we said that loss function and optimizer keys to configure the learning process. I want to ask Lucas to spend a few seconds. Just I give you a heads up if you are okay to pick the mic and explain the challenge that you had for loss function and why it was not working. So in next 2-3 minutes. But before that, I want to tell you that yes, we have loss function or objective functions. The other name is cost function. And it's going to calculate that error, and we pass it to optimizer and determines how the network will update based on the loss function. And this is something that we need to consider. If you look at the graph here, Give me a second, please. Okay, the thing is, how many loss function you think for that 10 output we are going to have? 1, 2, 3, 10, 100? How many loss functions do you think we could have for such a network? Anand said 1, Algar said 1. Okay, let me just read this for you. And now, after reading this, please just say your final opinion. It says that the neural network that has multiple outputs may have multiple loss function, 1 per output. Again, for such a network, how many you think we are going to have loss function? How many outputs do we have? Obvious. We have 10 outputs, right? 0 to 9. How many possible loss function we are going to have? The same. But is it possible to just calculate the loss separately and try to tweak the? It's not. So that is why the gradient descent process must be based on a single scalar and not 10 different values. This is the reason that we use the average, for example, of those. So for multi-loss networks, all losses are combined via average into a single scalar quantity. So whenever we want to decrease, guys, so in here, can you see that we have a loss function here, we have a loss function here, we have all the loss functions for all of these guys, and we calculate loss score. Let's just say that this is going to provide loss function 0 for us all the way to loss function 9. And we cannot fit this one to optimize there solely. So we are going to calculate the average, well, what is happening behind the scene, the average of L0 all the way to L9. So we are going to calculate the average of all this. And then based on that, we are going to tweak our weights and biases thanks to the presence of optimizer. Is it clear? If it is clear, please type 5. If not, ask me your concern and question. I'm going to explain it again. Okay, those who normally 10% is what we expect from the online classes. Is there any concern? Algor, Ali, Anand, Casey? Okay, so thank you. Look at this one. So by saying that, where is the? Yeah, there we go. So it says that choosing the right objective function or loss function for the right problem is extremely important. Let me tell you one example. If there is something that you already have similar situations and conditions, you don't need to reinvent the wheel. You can just simply use what they have provided to us. But it is possible to define your own loss function, but you should be very careful in defining your loss function. It should be very much aligned with the problem statement that you have. So it says that our neural networks you build will be just as ruthless in lowering their loss function. And the example, it says that, for instance, if you say that I want to maximize the life cycle of, or the life period of human being, one of the things that could happen is those robots that they receive this command eradicate all human beings except 100, and they take care of those 100 people and increase the average of their lives. So that is because we didn't define, hey, with the current number of people that we have, without harming, let's just increase the quality of life and the lifespan of those people, right? We didn't mention that, so it gives the possibility to them to just interpret it the way that it is easier for them. And it says that you need to be very careful in defining exactly. That's a kind of joke example, but it says that all neural networks you build will be just as ruthless in lowering the. And it says that, for instance, if you use binary cross entropy classification, if you have two classes, you need to use binary cross entropy for the loss function. If you use, this is super important, if you use many classification problem, you use a categorical cross entropy and so on and so forth. So now, Lucas, do you feel comfortable if you just open the mic and talk about your achievement, what you experienced?
Okay, yeah, can you hear me?
Yes, loud and clear, thank you.
Okay, perfect. Yeah, so when I was working on the project, I was just noticing that I could get you gave us two models to utilize. One was using, I believe, Atom as the optimizer, and then I think it was sparse categorical cross entropy. And then that one of them worked fine, but then the other one, which was using RMS prop and categorical cross entropy, was giving me some issues. And I was asking about what the problem was with that, and you were able to help me in terms of realizing that we actually had to use the two categorical method on our labels to basically allow us to process the data that could allow the categorical cross entropy optimizer or loss function to function properly. But at the end of the day, it's just showing that depending on what you choose as your optimizer and loss function, they process these arrays and tensors differently. So they will require different data preparation to make sure that they're okay. So these are just like little bits and pieces of information you kind of need to know. You need to know a little bit more about which optimizer and loss function you're going to utilize, and then properly modify your input data so you can get the correct output. So I was assuming that all the data preparation that we did earlier, which was the flattening, right, which was reducing the dimensions from like 60,000 by 28 by 28 to just 60,000 by 28 times 28. And then the normalization would be sufficient, but we had to also go that additional step and normalize the labels as well, which is what the two categorical did. So that's how we were able to figure it out.
Lovely, lovely. Can I ask two quick questions? So if I don't change the output and make them categorical, or as you remember, so if we just leave them as 0, 1, 2, 3, all the way to 9, what is the best loss function that I can use in that case?
Okay, sorry, my memory on this might be a little bit off, but I think sparse worked out initially.
Excellent.
Yeah.
Yes, sparse cross entropy. And if I change them to categorical, you remember that we have. So for this one, we're gonna say 1, and it's gonna be 0, 0, 0, because it is 0 all the way to 9. So the rest, and for 1, we are gonna say it is 0,
1, 0, 0.
For this one, it's gonna be 1 and 0, 0, 0, all the way to the end. So for this one, what is the best loss function that we can use?
For that one, categorical cross entropy.
Excellent, lovely, categorical cross entropy. So Stefan asked, that's absolutely fine, Stefan, thank you. And Albor said, will we develop the ability to set the right hyperparameters during this semester? We are gonna have some examples that we try, and you're gonna see it happens when we verify the loss as well as the accuracy. We are going to see if we change the values, like we increase drastically the number of neurons in hidden layers, what is going to happen. So we change the hyperparameters and we draw graphs. Also, we are going to make some bottlenecks, means we reduce drastically the number of neurons, way less than the number of outputs that we have in the second last layer, means the last hidden layer. And we are going to see and write the graphs for them and evaluate and see, for instance, from the accuracy of 80% we dropped to 70 some percent. So we lose something like almost 10%. So we are going to have some examples, but based on the limited time that we have, we can just have a few, like 5, 6 examples to experiment that. I hope I answered your question, Alvar.
Sir, just another question.
Yes.
So
No worries.
when we come into situations like that where I kind of had an issue, is this just, would you say this is just a matter of experience and just gaining an intuition by utilizing this stuff again and again? Or is there some sort of like fundamental piece that maybe I was missing that I'll develop later on in
Well,
terms of just
actually,
knowing this?
I see. Sorry. I thought that you're done. So do you remember that? Oh, what is happening here? I said that in this we have some general guidelines. For instance, if we have just binary classification, the loss function that we use for such cases would be binary cross entropy. And if we have multi-class single label, we use categorical cross entropy, right? We have some general guidelines for such cases, but long story short, I bring you back to the page that we started. Let me just get back here. And it says that picking the right network architecture is more an art than a science, Lucas. So we go through different projects, hopefully in this semester, and we are going to have some intuitions how to model our network. Before we say goodbye to the content of today, so we almost and if Lucas, I couldn't answer completely your concern, please tomorrow remind me. We're going to spend more time. But before we leave, can you please go to, wait a second. Can you please go to the quiz number 4 to your, yeah. And can you please confirm that you can see quiz number 4? The at class code is 9AIP. So let me just. Okay, awesome. Thank you very much. I wish you the best of luck, and we are going to continue our journey tomorrow. Have a wonderful one. I'm going to stop recording. Take care. Bye.